In this video, I'm going to show you a brief demonstration about the experiment determination of the electrochemical series. So I have everything ready here. In this experiment, what we're doing is measuring a voltage. And the voltage that we're measuring is just a cell potential. The cell potential that we're measuring is the difference between two cell potentials. We're using different metals and the solutions for those corresponding metals. In your lab manual, you have a picture of something similar to what I have here. And in this picture, I have the first one that I have here. It's a piece of the iron metal. And under the iron metal, what I have is the solution containing iron. Okay? So I'm using iron sulfate for that one. The next one, it's zinc. The metal that I have there, it's zinc. It's a piece of zinc. And the solution that I'm using is zinc sulfate. I have here aluminum nitrate, and these are the solutions that I have here in my tray. Okay? Aluminum nitrate is this one here, so I'm using aluminum nitrate, and I have a piece of aluminum metal there. Okay? The next one, it's tin, and I'm using your solution for tin. It's right here. That's tin chloride, and I'm using a piece of your metal tin. Magnesium sulfate is the solution, and I have a piece of your magnesium metal. Copper sulfate and a piece of copper. And then the last one that I have is silver. Now for the silver, I'm going to show you what I did with everything else. I have here in the back, I have my solution for silver nitrate. From that solution, I added 2 drops in the paper where I have my label for silver. And then on top of that one, I'm adding my little piece of silver metal. So I have everything, like each one represents a half cell. I have a half cell with iron. I have another one with zinc, aluminum, and we have 7 of them. Now what we're measuring is the potential, which is the difference of your potentials between the two cells that we're looking at. So I have the spark view, which is what I'm using to measure the potential, and I have some notes in here. Your potentials, the theoretical value, it's in page 120 in your lab manual, or the values for your half cells. Okay? And we can use those to calculate the value for the cell potential, in theory, what we should be getting. Okay? We're going to have 21 possible combinations. That's what I wrote here. So 21 possible combinations, because we're going around this. We have iron, and you can measure the potential between the iron, the zinc, the aluminum, the tin, and all the metals that we're using. So that's what I'm going to do. I'm going to show you just some examples. Now, before I start, we're using this equation like to calculate a cell potential, and your equation is the cell potential, it's equal to the cell potential that you have for the cathode, which is where the reduction is happening, minus the cell potential of whatever you have in the anode, which is where the oxidation is happening. Okay? Now, if you have a spontaneous electrochemical cell, the difference in your cell potential should give you a positive number. So we're aiming to measure positive cell potentials here. That's how we get 21 possible combinations. If we narrow down the possibilities to just the spontaneous one. And so that's what we're doing. So I'm going to start, I have here my alligator clips, which is what I'm using to touch the metals, and you will see the number changing there. So I'm going to start looking at iron and zinc, the first two, and let's see what happens there. There. So I'm getting a positive number, okay? So if you get a positive number, that's the number that you're recording in your notebook. Okay? So I have 0.42 volts. That's the cell potential for the cell that you have between the iron and the zinc. Okay? Now, if you use your alligator clips here and you touch your metals, let me try to do I'm using the iron and the magnesium. Okay? So the iron and the magnesium, in the way that I have my black cable touching the iron and the red one touching the magnesium. If you see the screen in your Spark View recorder, you have a negative number. So to get the positive number, just switch your cables. Now use the red one to touch the iron and the black one to touch the piece of magnesium. Now you have a number that is similar to the previous one, but as a positive number. So we go around and we do the same thing. That's with the copper, iron, and copper. You have the negative numbers, so I'm switching my cables here again. So for iron and copper, I have 0.58. That's the voltage that I'm measuring for that one. And this is how we measure the potential for all of the electrochemical cells that we're using. At the end of the experiment, you should have 21 potentials for all of the possible combinations.